All right. Good morning, DEF CON. Thanks for coming out to listen to this panel. Kathleen, I'm sure, introduced us, but we're going to be talking about the challenges with designing challenges, particularly ones that have high stakes in terms of the amount of prize money and working on a particularly important problem. And so, got a great set of panelists here today. So I'm really looking forward to just sort of digging into the process with them and having you understand what went into the planning and the design and the execution of the code bases, the vulnerabilities that were inserted, the scoring algorithms, the infrastructure. And of course, there's a large amount of artifacts that will be coming out of the coming from the program in upcoming weeks that I think will allow the community to really dig into the results. So why don't we just go down the panel super quickly, have people say their names so that people can associate faces and names, and just give 15 or 30 seconds on your background. David?
Hi, my name is David Brumley. I'm a professor at Carnegie Mellon University and the CEO of Mayhem Security. I'm also a founder of the team MMM/PPP, who's playing DEF CON CTF. I was brought in as a consultant on the scoring algorithm because our cyber reasoning system, Mayhem, won the previous DARPA Cyber Grand Challenge, which was in many ways similar to this one, but also the intent of this one was quite different. So I'm excited to talk about how that experience influenced my input and what was taken into this program.
Thank you. Tim Allison, CEO of Rhapsode Consulting. I've been an open source maintainer for more than 10 years on a number of Apache Software Foundation projects. Chair of Apache Tika. I've also worked on some other file parsing projects.
I'm Isaac Goldthwaite. I was had the pleasure of being the team lead on challenge design. My background's in AI and RAVR and across a handful of different fields, and really have got the pleasure of just helping this team use their talent to build cool challenges. So I'm really excited to be here.
My name is Haex. I have been coming here since DEF CON 13, so this is year 20. I have been playing CTF for the entirety of that time, or either running OpenCTF. So I was brought on just due to the amount of challenge design as well as active competition that I've been doing. I've been doing DEF CON CTF for 5 years. I ran OpenCTF for 5 years, and I am the CEO of Feisla. I was just recently last year in Forbes for my offensive AI research. So yeah, happy to be here.
Hi, I'm David. I'm a staff member at MIT Lincoln Labs. I've got a bit of a background in RE/VR, a little bit of hardware hacking, and I was just brought onto this program for more people making challenges.
All right, great. I mean, one of the things that was really important from a DARPA perspective with this challenge was making sure that it was focused on real world problems, right? So we could put together a toy competition and put together a scoring process. That's wasn't going to give us a real understanding of the state of the art, what was possible, and it wasn't going to allow us to change the world to produce automated detection and most importantly, patching capabilities. So I think the place I want to start with the panel was, how did you simulate those real world vulnerabilities? How did you get after creating realistic problems so that the results of the competition were as impactful as possible?
So I'll be happy to take this one, at least to start. On the Java side, I've been sitting on the security lists and the private lists for more than 10 years. So I've seen a lot of bugs come through. I know what's going on in our projects. As part of this, I also did further research on projects that weren't like ours, non-parser projects, if there's such a thing. So we also, in addition to injecting vulnerabilities that were novel, we also did some replays of actual known vulnerabilities, including Log4Shell. So we made sure that we were trying to imitate, mimic, and replay in some cases, actual vulnerabilities.
Who else wants to chime in?
I'll chime in from a little bit of a higher level. The foundation of what we decided to build challenges off of, I think, set a really good spot for making realistic challenges, right? Every one of these challenges was from a real open source repository. even the process of discovering and proving out the vulnerabilities found were through 90+% of the time were through maintainer created and maintainer approved harnesses. And so they are like already vetted naturally by the maintainers of those code bases to be like, I care about input to these places in my code. And so before even getting to the individual vulnerabilities, just like what we're looking at in terms of the challenges was rooted entirely in being real. So
Yeah, and just to piggyback off that, what Isaac was talking about were the harnesses, and for people in this audience know, but for those who might not, the harnesses are a way to focus on specific areas of the code base, and we relied as much as we could on the publicly available OSS Fuzz, Google's OSS Fuzz projects, harnesses that were developed by the developers of the project, saying these are the parts that we care about. We also did generate our own harnesses just for fun because we had to.
So, contrasting Tim's perspective, I don't have any open source maintaining experience. So the hardest part would actually be spending a couple weeks reading the source code of these things and trying to figure out what the heck these 20, 30-year-old projects are doing.
Sorry.
So I would spend weeks reading the code and just browsing pretty much, getting a feel for it at the same time looking for interesting or weird or bizarre behavior, which also wound up digging through a lot of man pages. So to throw out an example, like interesting behavior, realistic bug that would involve an edge case. Did you know that in certain cases, glibc will violate the POSIX spec regarding timestamps? If you ask it to parse dates that have a leap second, normally it will obey the spec and say, I don't remember what exactly it is. It either ignores the leap second or counts the next second. However, if you set a certain environment variable, the behavior will change, and instead of returning 0 through 59, it will return 60, which you can then turn into a fun out-of-bounds read or write using just a little bit of imagination.
Yeah, I mean, I think one of the things that strikes me is like, I've done lots of software development, but I haven't done vulnerability development. I haven't done security-focused development. It's really interesting to hear from the folks that like that's the mindset of how you look at code and how you think about it. And I'm super glad that we had folks with that sort of mindset developing the problems for the competition. Sarah, I don't know if you wanted to weigh in on the simulating real world vulnerabilities, or maybe talk about, I think another topic for the panel is like, how do you vary the degree of difficulty for the vulnerabilities that are inserted? So I'd be really curious to hear about that.
Oh yeah. So there's this whole metagaming involved. So in order to like correctly assess the teams to determine like who is the winner, who is the loser, you have to provide a varying range of difficulty. And so like this is a known problem for humans, and like I've been doing that for a couple of years, where you have a very easy series of problems, and then you have escalating difficulty, and there are challenges around designing problem sets that for a limited group of people or a larger team. And some of the CTFs around DEF CON have been exemplars of this. But the new challenge that we had to encounter here is, how do we test AI systems? We have all this experience around how people approach problems and how they go through that vulnerability discovery process. But how do cyber reasoning systems and their relevant components, how do they perform best with vulnerability discovery? And so we had an initial test in the semifinals around like, here's a series of challenges. We're going to throw these at the CRSs, see how they do, and then like take that information and learn from it and move on and do the finals challenges. And it was interesting because like I had approaching this from like a professional CTF player. I wrote a series of like very difficult to like extremely difficult problems for semifinals, and no CRS ended up solving any of my challenges. So coming into finals, I wrote a large series of Easium with a bell curve, kind of a lot of medium-ish challenges, and then some very high complexity ones. And I think that provided like a lot better spectrum of building differentiators between the CRS systems.
So something we learned from semifinals is we tried to um we tried to decide what we thought was hard and medium and easy, and we learned that we were very wrong. Um, especially when the design of that vulnerability and the event can have such a gap, and the amount of technology change in that gap can be so large. And so, our approach this year was not to try and be prophets on what is actually going to be hard, but rather to just also produce a big variety. And I'm actually like extremely excited to look into all of the archive data to know exactly like why were these hard and why were these easy. Um, but from our perspective, like we actually firewalled off a lot of what we were doing. So, for example, in the preliminary rounds we did, how CRSs performed was not allowed to be an input to us on how we design challenges. And so um, I got to see a little bit more, but these guys who designed the vulnerabilities basically never saw at all how CRSs were doing. So sorry for that, but in a cool way, it's like let's just make a big variety and let's find that out later.
Yeah, and just to add on to that, it's not only a variety of challenges. There is discussion about the ladders was dead on for what I was doing as well, for especially for path traversal with pretty easy, a little more interesting, very interesting with sim links and whatnot. But the other thing we were looking for was diversity of types of challenge. So, uh, especially on the Java side, we had more flexibility because we were using Jazzer. We weren't relying on only the memory focused C sanitizers, and I'll let David talk about that. But we had more flexibility, so we could have deserialization, we had SSRF, we had path traversal, a fairly broad range of challenges. Also, from my perspective, in Java parser land, we allowed for denial of service vulnerabilities in finals, which we did not allow in semifinals. So, out of memory, infinite loops, stack overflows, those kinds of things, which from a Java side are kind of bread and butter and also are important.
And did you work off a taxonomy of vulnerabilities? And you're like, okay, we want to have instances in each of these categories, or again, how did you think about covering the space?
From a Java perspective, we looked at what was available in Jazzer and what was easy enough to add into Jazzer within the time and would be reliable. We had to make sure that the sanitizers would always fire reliably against incoming data. And so mentally, in semifinals, I think we picked the top 20 CWEs for 2023, maybe. So those were in the back of my mind in combination with what was available in Jazzer or what we could easily add to Jazzer.
Contrasting that from the C perspective, our options were a lot more limited. The Java folks had Jazzer, which is fairly modular and extensible. Like y'all wrote a couple new harnesses. I believe you wrote the path traversal harness. Did you say that?
Yeah, we had a
Oh.
path traversal as a sanitizer. Yep.
So meanwhile, we were pretty limited to what was already upstream in Clang. So we got address scanner, undefined behavior sanitizer, memory sanitizer. Um, At the start of this year, we looked into type sanitizer, which is up and coming, but it wasn't mature enough for us to use. So we were limited to the big classes of memory safety bugs and a bit of undefined behavior here and there, integer overflows that were later exploitable. Which of course, 70% of bugs in C are memory safety, so it's not like that's insignificant. But it did limit our flexibility a bit. When I first came onto this program, the first bug I wrote was a path traversal bug, and we had to discard it because there wasn't a good sanitizer to trigger it.
Yeah, and to continue off of that, we did want to ensure that we had a representative range of memory vulnerability classes, specifically for C challenges, not necessarily talking about Java. But we had plenty of use after freeze. We had buffer overflows. We had heap overflows. We had type like object type confusion. We had object use after freeze. So we tried to provide a large representation of the existing like vulnerabilities that we see as CVEs, so end days that you see coming out.
Yeah, I think too, just on diversity of the challenges, we have the like what causes the crash, right? And then we have the what is vulnerable that leads to that crash. And then we also have on top of that, like take those and build them into challenges in different forms for the competition. And so some of the diversity we had on challenges was like the full and delta scan, which I won't go into full detail, but basically asking the CRS to analyze like a entire code base or just a PR. And we had deltas that were very small. We had deltas that were massive, and the CRSs had to deal with how to manage and not just waste all of their compute and all of their budget on millions and millions of lines of code versus like sometimes thousands of lines of code. And that diversity, I think, played a big role as well.
Yeah. So, I mean, obviously, you could see like a lot of thought went into the development of the vulnerabilities themselves, and obviously we'll have a better understanding of how the CRS is scored against different vulnerabilities and dig into that data set. I mean, I think there's very interesting questions to explore, like the difference between the intuition in terms of what was hard, what was actually hard for the CRSs. Is that because the CRS systems somehow are better in some ways than humans and weaker in other ways? And so those are things that we'll be able to learn sort of in retrospect, digging into the competition data. David's been sitting here patiently, so I want to move on to another really important topic, which is really about scoring and incentives and the mechanisms for that. So, David, maybe over to you to start the discussion about the scoring process, the design, red teaming, and then we'll dig into that.
Yeah, I do want to discuss this because at the end of the day, all the competitors had different areas of excellence. And so you run into this question, and I'll just ask you to think about it. Who's the best hacker? And if you spend a second thinking about that, you may say, well, what do you mean? Is it finding new vulnerabilities? Maybe that's George Hotz, GeoHot. Or maybe it's the one who's the quickest at figuring out how to patch them. Or maybe it's social engineering. There's all these different categories that go into this, and everyone has their different, perhaps, weighting on that. So we took that same philosophy into the scoring algorithm, where there was categories. How well, when you patched, were you able to fix bugs? Did it impact performance? How good your discovery was? And then instead of assigning just a specific point value to each one, we instead ranked competitors against each other. Think of it like you're in a classroom where there's a bell curve. If you rank people on a bell curve, there's a number 1, a number 2, a number 3. And that's kind of what we wanted in each category. The advantage over that, as opposed to points, is everyone could get the same number of points and you have no winner, right? So we first decided we're going to rank them competitively this way. And then we're going to emphasize as the core of this contest, defense and patching. How well they could correctly create a patch. Is it succinct? Does it not break existing functionality? And weight that the highest while still giving credit to these other pieces of functionality. So we went through this, we talked to all the competitors, got their feedback, and then iterated on it based on some of their concerns and their beliefs, taking that sort of approach, and then built simulations to go through it and tried to figure out not where someone could game it, but perhaps where the scoring algorithm would give an unfair advantage for something we weren't thinking of, right? It's a real competition. People should be able to optimize and get the millions of dollars the DARPA was generous enough to give. So we put a lot of thought into this, and the TLDR is it weighs several different areas of excellence. It weights them across how people relatively do to decide the winner. And so you do end up with cases where the winner you see up here is amazing tech, but all the competitors had areas of excellence for which they were the best. And I think that's an important outcome here.
Yeah, I'll just foot stomp the importance of the patching piece. I mean, if you think about critical infrastructure software or the open source ecosystem in general, it's often under-resourced, right? And sometimes dramatically under-resourced. I think we've used the reference to the AIxCC cartoon with the little block that, if that goes away, the entire stack can tumble. And so that was that's part of the reason for the focus on the patching. That's why the patching piece is so critically important. it's not necessarily that we don't know about the existence of vulnerabilities, but the ability to do something about it and the ability to do something about it at scale and in a resource effective way, I think is critically important. And so, in particular, as David said, different weightings for different elements of the scoring algorithm.
Yeah, if I can chime in, some of the biggest key points of emphasis in terms of our thought process on what we wanted to incentivize too was we wanted to lean into actually rewarding reasoning and not just like cyber systems, but actual cyber reasoning systems. And we also really wanted to reward and consider maintainer empathy. That was a huge part of our design for both the scoring algorithm and just all of the infrastructure stuff too. For example, like Tim is a real maintainer up here, but if I pretend I'm a maintainer, I imagine like maintainers don't just want a proof of vulnerability. Like it's valuable to report that, but it is kind of annoying to just get that and not get a fix, right? You also don't want a bunch of patches that are like, here's problems, but I don't have any proof for those problems, right? And but also part of the game, you don't want just a patch with one problem. Like part of the AI Cyber Challenge this year was patches needed to solve all of the POVs across all competitors that were relevant to that vulnerability. And so if you submitted a POV for the same vulnerability that I'm trying to patch, but my patch only fixes mine and not his, my patch wouldn't score. And so we have this like built-in patch quality testing mechanism. And then ultimately bundles is the reasoning side of associating this patch is associated with this set of POVs. And even to the degree of like, this is related to that code scanning alert that happened on this program too. And here's some more, provided text description. And we really wanted to lean into valuing the reasoning side of things. And from the perspective of, as a maintainer, what would be the best gift from an AI system? And we figured all of those components would be that.
So thank you. I thought that I was just being myopic and in the desire to make things easier for maintainers. In the back of my mind all the time were all of the blog posts from, I believe, Daniel Stenberg from Curl about all of the AI slop he's been getting on his issue tracker and the bug tracker. Oh, we found this. Oh, we found this. And he ridicules them because they're not meaningful security bugs if they're meaningful at all. And that's one of the things that AICC was really, from my perspective, and I think this was kind of baked into the scoring, trying to make sure that we weren't just throwing out AI slop, that these things actually had, these were important vulnerabilities and that the patches actually fixed them, so we weren't wasting maintainer time.
One of the things that I saw that I was really happy with from a leadership perspective as I was watching some of the stuff develop was things like simulating the scoring and red teaming. I'm wondering if David or Isaac or others want to talk about that a little bit.
I think it was what we said, where I built a program in Rust where we could go through and we could run pseudocode to say this is how the different artifacts would weigh out. And for example, when we were looking at this, we said, if we start weighing POVs too highly, we're really incentivizing this idea, very similar to like the previous Cyber Grand Challenge and not so much fixing. And so really, at the end, the simulation kind of gave us this insight that the POVs aren't offense. They're just proof that there is a vulnerability. And we kind of just treated them as such. As we had this problem that we didn't know what all the vulnerabilities would be in the code. There were certainly those inserted, but we expected competitors to find unknown vulnerabilities and did it. We also wanted to reward competitors for creating patches for which they did not have a POV, but might have fixed a POV someone else had proactively. And you run into this problem, right? You don't want people modifying every line of code with an if then else, if malicious then, or what we call a Superman patch where they run everything under Valgrind as opposed to actually fixing the bug. And we use those simulations to kind of suss out those ideas and come up with a weighting algorithm to make it fair. The other thing that we did in these simulations is we tried to root out everywhere we would use human judgment to decide where something was. And we had lots of discussions with the team with Kudu, and they were very receptive, where it was like, this part of the scoring, you're saying, let's go look at the quality, but it seems very subjective. And what you may think is good patch, maybe Linus Torvalds would say is complete garbage, right? So let's figure out the algorithm so that at least everyone knows what they're optimizing for.
Were there things that evolved in the scoring process or the scoring algorithm from the semifinals to the finals, or did things remain static?
The algorithm, it's hard to remember some things from semifinals this week.
So long ago.
The algorithm is certainly different. Exactly how different is not on the top of my head, but the gameplay was very different. So I know that Andrew Carney, he displayed a really cool visual of like what was scoreable in semis versus what was scoreable here. In semis, it was POVs and then patches that fix targeted POVs. That was the whole semifinal competition. This year, it was POVs, patches that can fix one or more zero or more, but scoring one or more vulnerabilities, serif assessment responses, bundles, as well as a lot of optional non-scored things the CRSs could do, which could like show off some of their expertise, and that was very cool.
There's actually a couple of things you're kind of coming out of this that I know you changed between semifinals and finals. For example, in semifinals, there wasn't a way to automatically score unknown vulnerabilities, and you added that in during the second one, because I think you said we're going to replay our POVs, and then in the finals, you said we're going to take all the people's POVs, and that's going to determine the set of vulnerabilities. So if someone found a new one, that changed it. In the semifinals, there was scoring for POVs had just a raw point value, and you ended up coming up with some weighting in that because the problem with a POV is it's a little bit in the eye of the beholder what the vulnerability is. You could have something that reads in user input and then calls two different functions with string copy, where there's one patch where you just check the input length at the original place it was read in versus two patches. And we were trying to suss through, like, should you reward two micro patches versus one more general patch? So I think there was a lot of evolution on specific points, like dealing with unknown, as well as increased insight into how you think about this. Because I remember Theory told me, and I told you, we found things where we could count 3 different vulnerabilities, but we knew it was only one. And so we took that impact, and there's only so much you can do mathematically and algorithmically with that insight to make modifications.
So I want to expand from the scoring algorithm into the testing infrastructure, which is obviously closely related to that. And it seems like that could be an important artifact that comes out of the competition itself. So Isaac, maybe touch on that a little bit. Talk about what that scoring infrastructure looks like, does, how it might be useful to the broader community.
Yeah. So there's a lot of details that I've been trying to go over here, but at the broad level, every single thing that happened in the entire competition, from anything that our infrastructure did, anything any individual CRS did, including things like the CRS health checks, like every bit of detail is logged in an audit log where we have absolutely everything. And that audit log, along with the objects associated with those events, was the input to our scoring system. And so we made sure that there was never anything that was not being considered or lost because of whatever. And then our scoring system, which actually will be available at some point, I don't know the date, but we go through many tests and retests of certain things, as well as respecting all of the game time events. So the communication that was sent to the CRS at game time, we obviously respected that, but we also would double check that it exactly what happened then is reproducible. And so we have a lot of the numbers on actual compute hours to do some of the processing of the game was comical sometimes, like near hundreds of thousands of hours of compute, which we happily optimized to be much lower. But it was cool to see all of that, and then the aggregate of all of those. Again, the algorithm is scored on a challenge level, and then we did a full, long, good, deep process of reviewing every submission by hand and with groups, and making sure that all of our decisions on anything was made with a like consistent mindset towards how we're treating all of these things. So there's so much to talk about in terms of the details there, but the process was a lot of fun and a lot of work. So
David?
So the review process, Sierra, Tim, jump in on this as well. We reviewed every single patch submitted to every single challenge project or challenge repo. So that was to ensure that they weren't gaming the system by breaking stuff. Sometimes they were. We discarded a fair few patches. I distinctly remember reading this one that patched a format string bug by adding some conditionals inside the printf function. There was this other time that I wrote a broken challenge, extremely broken challenge, broken in many ways. But one of the ways it was broken was the test system I wrote that checked, does this pass the CR's functional test, did not work. I wrote an off by one bug in the test script, which meant that it wasn't actually possible for them to ever fail. And in that challenge, we had a bunch of patches that accidentally disrupted the test infrastructure by forcing tests to pass that should not have passed. So that wound up getting really confusing, and we had to discard a whole bunch of patches and let others through just based on the individual patch and what exactly it was doing.
and the decisions on those review things will also be available, and they are a little bit tweaked from what you just described, but are the amount of like basically we did our due diligence to make sure that if there was any point of competition error on our side, that we made sure to ensure these scores were not, or no team was penalized because of that, and that things were fully fair off of those things. And so we also have that data available. I can say it's far less than 1% of cases, so that was also wonderful to see that in a low number. So
I think before we move on from the testing infrastructure, just one other line of discussion about the scale of it. Like we've heard from the performers about the challenges of putting together a large system to, find the vulnerabilities and automatically patch them, and the size and complexity of their systems. Maybe you could talk a little bit to the size and complexity of the scoring system, because I'm sure there's similar challenges.
oh yeah, so scoring systems specifically, not challenges. Like man, I would love to go into a lot of detail, but I didn't design it. I do know a lot of the internals, but yeah, I'm not sure how to summarize, but this may be better something to look into the release of the information after the competition, honestly.
I'd like to add just an anecdote. So we won something called the Cyber Grand Challenge many years ago, and we were super happy. Mayhem is this great system that wins. We go out to market. We focus on how good we are at finding vulnerabilities, and we thought we won. And actually, where we spent most of our engineering time was on things like triaging and deduplicating things. So there's a huge amount that goes into this that often we forget as security people downstream from the maintainer are those multiple bug requests. We all in security love sanitizers for finding bugs, but go and try to build a system that parses that. The designers of that, Google, decided to make it human readable as opposed to computer parsable. And so you end up with, I remember having a discussion with you, Isaac, about these crazy regexes to try to figure out what the sanitizer was. Because again, we're not going to have a human go through these. That introduces error. So when you're talking about a scoring system, really what you're talking about is almost that system that the developer has in front of them that summarizes, condenses, and deduplicates from all the different sources to try to identify what the unique behavior of the bug is in the implications of the patch among several competing submissions. And that triage process is like real.
Yeah, maybe just as a wrapper on the complexity of things, like we went through every submission by hand to review it, but that wasn't to score it. We went through every submission by hand to make sure we weren't messing things up and that competitors weren't cheating. But the system that like actually processes and produces the score, and David, you've mentioned a couple of points on this, like we designed a challenge that has objective points and objective value. And that process is complex, and it's cool that all of that is fully automated for us. And so that scoring pipeline will be available. And the manual review is, let's double check. So.
Yeah, again, I appreciate the diligence that I saw from the teams working on the evaluation side. Got about 8 or 10 minutes left here, so I want to touch on a couple other areas. Be really curious to hear from any of the panelists on things that you wanted to do but couldn't because of the format of AIxCC. Some of that might be fully automated, um, you know, um, fully automated capabilities or fully automated scoring or the scale of it. But were there things that you wanted to do but couldn't? And maybe that leads into like, where do you see like follow-on efforts or research going?
Yeah, I'll jump on this too. About a year ago when we were talking about what do we want to change from semifinals to now, we had a really fun discussion on here's all the responsibilities that we are taking on from the competition side, and here's all the ones that we're making the CRSs deal with. And we toyed with the idea of what if we move all of those to the CRS, and we landed on that's too mean. So we got to pull some back. And there's a few things like that I think, especially after seeing the change over the last year and how well some of these teams did here, I'm really excited to see what it looks like to see some of those removed. One of those in particular is, we provided a standard build, a way to build these challenges because the CRSs never knew what the code bases were ahead of time. I'd love to see what it looks like for CRSs to have to build challenges when we don't give them a standard way to build it and they've never seen it ahead of time. Like read the README, have fun, and give me something valuable in response. I would love to see that.
Yeah, and to add to that, again, something that's out of scope for this program is automatic harness creation. Some of the ways that I developed my vulnerabilities, or at least the POVs, was by creating micro harnesses on specific parsers. For example, within PDF, I did a couple of font parser harnesses for some of the POVs, and giving the CRSs the chance to create their own harnesses to allow for finer grained harnessing for fuzzing and for their own methods would have really changed a lot of things. It would have opened up the scope and the purview of a lot of these systems into these larger code bases for the future, not for finals.
I'd like to echo that. Like harness creation in our go-to-market is probably the biggest barrier. NIST guidelines say you should fuzz. MDA, Cybersecurity Missile Defense Agency, cyber requires fuzzing. Aerospace has a fuzzing requirement, automotive. The reason people don't do these things that we think are straightforward in security is they don't have the time to write harnesses, which are things that focus security analysis on the parts of the code that are on the attack surface. And so doing that and bringing that in is a huge one. The second thing is this contest was very much focused on DARPA's core objective of looking at where there's a lot of bang for the buck in memory safety. Outside the scope was what I would call a typical pen tester set of vulnerabilities. For example, IDOR in web, cross-site scripting. These are important things, and they're quite honestly just as numerous as CC++, but it tends to be that site has an XSS because it's their code, but also only written by that site. While C, you have this prolific effect that it's used in all the infrastructure. So there's a bigger class of vulnerabilities. When you look at different languages like JavaScript, there's new challenges. How do you deal with strings? And then just for what we did today, there's the question of how quickly can you onboard the code because of some of the constraints for running a contest. I had to remove those to make it fair.
Sierra?
Yeah, as a challenge designer, there were a couple things that I was thinking about and looking forward to as like future potentials. Some things that I designed that didn't make it into finals were injection of non-vulnerable code that introduced vulnerabilities. There's a series of systems that are plugin based, and each individual component within those systems is individually secure and safe. However, there are larger trust component issues between each of the components that are interdependent between each other. And there's also like the very hard problem of multi-threading and finding concurrency issues that are where real world bugs, say for example browsers or kernels, are currently failing at. that we really like to see how a CRS would perform against. So
Yeah, that's 100%. There's also a question of mitigations. Look at Chrome, right? When someone says I can hack Chrome, you're typically talking about multiple vulnerabilities. You may have a sandbox escape, and then you have to do privilege escalation from the renderer process to the browser. Those are separate vulnerabilities. And it could be there's a defense in depth and good architecture, and how well that defense in depth. The way I think this program looked at it is any vulnerability should be fixed. Let's not rely on defense in depth, which is honestly the correct. Defense in depth there is a failsafe, not I was going to say not a defense. It is a defense, but you shouldn't. It's a failsafe, right?
All right, maybe last question as we wrap up in 2-3 minutes here for the panel. So and so quickly, we'll just go down the line, and maybe we'll start with David and then work our way back. Would you do it again? And what was the best or the worst thing? So David, we'll start with you, but quick answers.
Which one?
Oh, sorry, Dank.
Both same time.
Yeah, David Dank.
Sierra and I'll go at the same time too.
Me first.
No,
okay.
Most interesting thing that happened. Dissecting Odays. Watching the rounds run and seeing, oh, this POV doesn't make any sense. That has nothing to do with the code I touched. So some of it was me just exploring this piece of code and typing this query into a system and getting segmentation fault as a result instead of a meaningful answer. Watching the SQLite Ode, having that land on my desk and dissecting it and figuring out how that happened. Dissecting bytecode compilers. There are a couple Odes we can't discuss right now because they're going through disclosure, but dissecting them was fun. Reading a lot of really weird code. Figuring out ways to make it break just by relaxing constraints just a little.
Great, thanks.
Would you do it again?
Yeah.
Sierra?
I can confidently say, yeah, I would do it again. We've discovered like all the vulnerabilities previously discussed. Like there is tangible good coming out of this program that is helping the open source community and helping us build a better and safer internet. So just that alone is fantastic. But like going through all these code bases that have been around for 20, 30 years has been like one of my highlights, and seeing not only just the history, but the diversity of programming styles. It's made me a better programmer, seeing like, to be honest, some of the awful programming styles we've had to go through and like understand as each of these individual little projects. So it's been like a survey of software, and it's been a great time.
Oh, I do want to tack on to that. As a challenge author, I think we had maybe a quarter as much fun as the competitors, but it was extremely useful and meaningful and impactful to build this challenge, because now we've got these systems that are going to be out there in the world fixing problems. And I'll tell you, I cannot wait to go home after DEF CON and start tearing into their source code.
Great. Isaac?
Yeah, I would do it again. There's a lot of lessons learned on how to delegate work and how to think ahead and be proactive about in a much more conservative way. I think something I'm excited about that I lost it. It was in my head.
I mean, you mentioned in the past just digging into
I mean, I'm so excited to see the data. Yeah, I'm excited to see the data. If we did it again, I'm really excited to remove some of the competition barriers. Mostly the barriers between like this team, our sub teams, and the competitors. Super glad we did it for the competition. It would be really cool moving forward if you know, the transparency among all of the collaborators and just like the open source community. I'm excited to see where that goes. Right.
Yeah, so from my perspective, definitely doing it again. I learned quite a lot about security. My high point was just watching the big, large scale, the difference between the systems at semifinals and finals, which was just staggering. They had more resources. The systems were just so much better. The patches were amazing. There's one organic free range vulnerability that was found that we did not put in that required a patch that was extraordinarily complicated, and a system generated found this free range vulnerability and patched it with a really complex patch, and it was just astounding. Lots of work still to be done, but I was really impressed. David?
Um, so I think if it were to happen again, I think it needs to happen again. We know from the previous challenge, and we look at just the world stage, we know last time we ran one in DARPA Cyber Grand Challenge, China ran 6. We know that people are doing this. And so I think we should all not just see as whether we want to or not, it's something that the community needs to do, is to continue to run these because they push state of the art. I think one of the challenges is just the human toll. So it's interesting that you said this. I'm friends with many of the teams, and on this short timeline to get a non-traditional performer to recruit those teams and devote it, most of those teams were doing other things. And even when you have an extra $1 million sitting on the side or 5 million, those other things don't go away. And so it's really interesting to see how people kind of went down because of the excitement of it. So I think it needs to be done. For me personally, I think when the original contest came out, I had a lot of concerns. I was very public about them. And so one of the things I do appreciate is DARPA is the type where if you have concerns, and they're reasonable, of course, they said, why don't you come help us? And so I do think I would do that again, because there is that attitude where when you say, hey, this doesn't look good, as long as you're willing to talk to them, they'll listen and incorporate those. And I value that.
I think AIxCC changed the world. I think demonstrating that you can patch effectively at scale in a cost-affordable way is going to be transformational. There's a lot more work to be done, but I think that is going to change the world. And that wouldn't have happened without the hard work of the folks on stage and many, many others. So please give them a round of applause, and thanks for your time in the country.
Yeah, I also want to, the talks about challenges, I want to do a shout out to the other challenge developers too, and the Vault developers, because we have us three, we have HJ, wherever he is. We have all the other people at MIT Lincoln Labs. Thanks to Chris Domas for helping out. Thank you to a bunch of Kudates for helping out, like just many, many, many people. And the data you guys are all seeing is about half of the data that is actually used to make this whole thing happen, with all the preliminary rounds we ran and everything. So just thank you guys, and thanks everyone that is abroad that have helped with this. So,
And thank you, Isaac.
All right. Thank you.